Thank you, Panchi. Greetings, everyone. It's good to see a hall more or less full on a Tuesday morning. We expect a lot many people to join in, and I'm sure through the course of the day, we will have participation going up. But I truly appreciate you coming here today for what is for us a very, very important initiative. Mobility Future Tech is something that we curated around March, April of this year, and we said we have to focus on areas that are of critical importance for the future of the mobility industry. So we started thinking of what are the subjects that we need to sort of look at under this domain. We started with a conference on advanced driver assistance systems as well as autonomous driving. We had the first session of Mobility Future Tech on the 8th of June. Satish was very much part of it, so was Kaushik. This is the second edition, and we are focusing on software-defined vehicles. The third session under Mobility Future Tech will be a focus on cybersecurity, and I would welcome your feedback, your suggestions on the subject, on how we can curate that program. Ladies and gentlemen, many of you who have been following our journey, Mobility Outlook is just about 28 months old. We started in April of 2021. And in the course of this 2.5 years roughly, we have been able to not just create some exciting properties covering different aspects, but have set benchmarks in many ways. You would be aware that we have, under our intelligence domain, created India's most comprehensive consumer study. We call it the Indian Automotive Consumer Canvas. And that has become the most comprehensive, the largest, the widest, the furthest as far as consumer studies are concerned. Last year, we closed that survey with responses from 2.56 lakh people. So you can imagine the kind of reach that we have got for our consumer study, and Kaushik has been a key part of that process. Thank you so much for that. One of our other initiatives is called Women in Mobility. We are already into the third year. Now, Women in Mobility is not just an initiative where we sort of honor, feature women leaders from the mobility sector, but under the Women in Mobility domain, last year we initiated a program called Champions of Diversity. Champions of Diversity is an initiative wherein we look at organizations working in the areas of diversity, equity, and inclusion. It's a small start, but a very significant start as far as we are concerned. Likewise, we have created conferences on electric two-wheelers. We do an event called Making Mobility Safe and Secure, focus on safety and security, as well as powertrain. At this stage, ladies and gentlemen, before we get to the core of what we are doing today, I want to introduce to you and announce a very critical, a very important, in fact, a marquee event as far as Mobility Outlook is concerned. That is the India Sustainable Mobility Summit. We have a standee right here. You can have, and we'll be happy to share more details on it. This is a 3-day international summit on mobility ecosystem, wherein we are going to focus on the entire ecosystem, not just on the product. So we're going to talk about energy transition, circular economy. We're going to talk about clean mobility, climate finance, etc. It's a very interesting property that we have created, and I hope all of you actively take part in this initiative. This is also important because, one, it is unique. We have support already from Niti Aayog. We have Terry as our summit partner. We have knowledge partners like Markets and Markets, Deloitte, Nomura Research Institute, as well as Grant Thornton. And I'll be very happy to share more details on ISMS, should you wish to have more details on that. Now, coming to Mobility Future Tech, ladies and gentlemen, we have brought together the subject of software-defined vehicles as well as cybersecurity today. While talking of SDVs, we obviously cannot not talk about security. Highly connected, these vehicles exchange a lot of data between various components. sensors, and networks. Right? This is precisely the reason why we have integrated both these subjects into the conference agenda today. It's a packed day with, we have two panel discussions, one focused on software-defined vehicles, the other on cybersecurity. We have two keynotes. Thank you so much, Dr. Tapan Sahu from Maruti Suzuki, for accepting our invitation, Mr. Bhange. We have two keynote addresses here. We have a special address by Mr. Tarun Garg, COO of Hyundai. He's going to join us around noon. We have 6 technical presentations on various aspects of SDVs and cybersecurity. We also have a fireside chat with Dr. Kirsten Michels. He is the head of HPC at Continental Automotive. He's going to join us around noon again. And of course, right after this inaugural session, we will have a presentation by our knowledge partner, Markets, and Kaushik will share interesting insights on the subject of SDVs. Just a bit on how I look at SDVs. Of course, it's such a dynamic subject, and I'm someone who looks at SDVs and cybersecurity from the outside. You are the audience here. You work on the subject from the inside, right? You know much more, and I would leave the experts to sort of share more details on what the subject entails. But if you look at the global megatrends, call it CASE, call it ACEs, whatever, there is, you can't not talk about digitization as well, right? And the potential that you see in this area is truly immense. A McKinsey study sometime back had stated that software as a percentage of the overall vehicle content will grow at a CAGR of 11%, right? From about 10% in 2018 to about 30% by the end of this decade, right? And so clearly software as well as artificial intelligence represents new value propositions for the players in the industry. Among various other things, one of the biggest challenges facing today's vehicle networks is the vast amount of data that is produced. This will increase exponentially as vehicles become more autonomous and connected and are required to process vehicle-to-vehicle or vehicle-to-infrastructure communications. It is believed that SDVs will open new monetization strategies and opportunities with features on demand, and will also unlock the potential of cloud-centric development and lifecycle. While opportunities are limitless with the role that software will play in future vehicles, there is no denying the fact that compliance and regulatory challenges will remain. And I hope through the conference today, some of these questions will get addressed. So as you can see, as I said, we have a packed schedule today, right, going up to about 5:36 in the evening. And I hope that you have a lot of takeaways from this conference. I hope you find this conference meaningful. And I would request all of you to participate actively, be part of the interactions, ask questions to all our experts. And I'm sure that is what our speakers would also appreciate. So I welcome each one of you once again to this conference. And I would now request Mr. Anand Bhange, who is the head of FEV IO India, to deliver his keynote address. Thank you so much. I would be failing in my duty if I did not thank the sponsors of this conference. It would not be possible to organize such an event without the support, active support of partners, our presenting partner FEV, our software-defined vehicles partner ETAS, and our technology partner Vector. And of course, our knowledge partner Markets. Thank you once again. And Mr. Bhange, over to you, please.
So, good morning all. I think first of all, I would just like to congratulate everybody on the success of Chandrayaan 3. And now today's topic in terms of automotive innovation. We are talking about innovation. So a very good example of innovation. When we say innovation for smart future, I think this is one of the classic example of how NASA has already deployed a rover on Mars. It was designed for around close to 2 years, but operated more than 15 years. And this was only possible because of, during this journey, there was a lot of software updates done. And mainly the software updates not only just to add features, but also to improve the overall functionality of the system. So one of the examples here talks about, so they were facing problems on the wheels. The wheels were getting degenerated quickly, and they wanted to protect those wheels. So they developed a complete new algorithm. And with this algorithm and a full software update, they could elongate the overall life of the system. This is a very classic example of innovation, and which means now you have to design a system which is for future. This is only feasible if you design your hardware for future and then do the continuous software updates as we move along through the product life cycle in terms of usage of the product. Yeah. Now, getting back to the original subject of why do we need software defined vehicle. So if you look at automotive world, it is changing in 4 quadrants and in all directions. So end user expectations are changing. I think the OEM expectations are also changing. The end user need something like your mobile experience, consumer electronics experience in the car. There are the complex functions being introduced in the car, and while doing so, there are new technologies are also evolving. So typical way of doing a manufacturing or designing a car where it used to take 4 years, now the technology itself becomes absolute in 4 years. So you have to plan in such a way that you are not only ready for 4 years, but you are ready for 10 years from a technology evolution point of view. So how do we utilize or taking all these challenges of changing automotive industry and still deliver wide range of mobility? So we are talking about right from micro mobility to full scale mobility. There is a lot of growing influence in terms of complexity, and the overall E architecture itself is evolving. So how do we solve at one end the complexity of the functions, and on the other end time to market is reducing? So the only answer is software defined vehicle. And we will also look at, when we say software defined vehicle, what are the key considerations? What are the key top 5 requirements of considering a software defined vehicle? I think the first one is, today any of the new use cases are no longer in vehicle. The use case sometimes can be in vehicle, sometimes it is in outside the vehicle, like connectivity, and the use case can also be extended to the cloud. So when I am thinking about adding a new function, I do not think about whether it is an in-vehicle function or outside vehicle function or cloud function or combination of these 3. A function can be anywhere. So any new use cases has to cater multiple computing options spread across. The second core requirements is basically how do we solve this complexity, which is already solved in IT world. Many of the very complex IT problems have been already sorted out with a term called as cloud native platform. And of course, while bringing them in automotive, we must talk about the core automotive requirements. But why not learn from IT world and bring same technology to automotive world, keeping the core automotive requirements as is. So you must have a cloud native platform wherein you can have virtualizations or containerizations or equivalent technologies, so that you can have isolation in terms of, let's say, safety and non-safety real-time, non-real-time functions together. And then also decomposing all your use cases, functionalities into sort of services which can be span across multiple virtual machines, multiple HPCs, or multiple ECUs. Sorry. Of course, the third core requirement is, so today any of these services or any of these functions are deployed in multiple ECUs and they talk over CAN bus, a typical example. But when it comes to computational across multiple options, you cannot have one bus. You have to have a common bus which can talk from, let's say, a service running on one virtual machine to the other virtual machine. The same communication mechanism can be utilized from one HPC, when I say HPC, high performance computes, to another high performance compute. Or if I am having a service which is running on a in-vehicle high performance compute, talking to cloud, the communication mechanism has to be same. And that's where we are terming it as virtual bus. Underneath it could be anything, physical bus can be anything, but my services only knows the virtual communication mechanism from point A to point B. Of course, the fourth core requirement is, when it comes to automotive, functional safety and cybersecurity are the core ingredients. You cannot bring them afterward. You have to think about functional safety and cybersecurity from day zero. And right from the platform to the application to the all levels. So cybersecurity and functional safety are going to be there as a core automotive requirements. And we cannot go away, though we are learning from other domains, we will still have these as a core requirement. And of course, the final one, because we are bringing HPCs and more high performance computes, we will also need additional components in terms of for creating ecosystem, the software development kits, the high performance resource management. So because there are multiple shared resources will be utilized from the hardware standpoint of view across different services. So we will still need all these management activities. And at the beginning, we talked about software update being a very, very core requirement. Over there, updates will be kind of must have for any software defined vehicle. So this is overall requirements. How does this translates into an architecture? So again, we are talking about a reference architecture. Of course, this can be different in different cases. So for example, the blue ones are HPCs. It could be one or many HPCs in the car. The edge computing is outside the vehicle, but still a real-time processing requirement. And the cloud computing is still something which is on the cloud. You will still have legacy ECUs, which are also shown in the red part, the mechatronics part. So you will be in the transition phase. You will have a hybrid architecture where you will have legacy ECUs and high performance compute ECUs. And after the transition period is complete, it will be more full HPC oriented vehicle architecture. How does this translate from a business point of view? So there are in-car services. So those will also be redeployed, redesigned, re-architected based on the new architecture. You will still have vehicle to vehicle and vehicle to intra communication. So for example, talking to a roadside unit, communication with a smart city infrastructure. So those will still have similar use cases. And of course, we are also talking about a lot of business integration like payment gateways or digital twins, data analytics. So all such kind of use cases will be an extension of the vehicle on the cloud. So with this, how do we define a true software-defined vehicle characteristics? I think the core requirements, again, I would reiterate updatability and upgradability. I think managing the complex software is one of the core requirements. Then when it comes to software defined vehicle, I think one of the core requirement, you have to fully decoupleize your hardwares. So it has to be fully abstracted, so that if I write a piece of software which should be reusable for the next program, even if I change my hardware, my software doesn't remain a completely new software. I am just configuring it for the specific deployment. And of course, with this, we will have to take care of driving experience, new business models, like pay-per-use, subscription-based, and there will be a lot of new ecosystem players and contributors to this overall ecosystem. How does that translates into kind of business models and solutions? I think all the features will be translated from the software point of view. Of course, the continuous software update, increasing safety and security, those are kind of requirements. There will be a lot of activities in terms of how do I bring the time to market and cost reduced with this software defined vehicle, and a lot of add-on services. It will not just be selling a car, your monetizations will be after selling the car. So a lot of business models will evolve after the car has been in the hands of end customer. Of course, with this, the core requirements of automotive, we call it as connected, autonomous, shared, and electric, those will be fulfilled with this kind of requirements. A product development will also change because of software defined vehicle. So though the center part from the name itself is software, you will still need electronics and mechanics part of it, but the lot of majority of the development will happen on the software side, and hardwares will become commoditized. A classic example is today's smartphone. The smartphone hardware is very, very common. A lot of companies can come up with a hardware, but of course there are many smartphone companies which still have a unique identification and value proposition in the market. So that will still be there. Of course, all this will also need a reorganization in the OEM as well as tier 1 standpoint of view. So how do we deal with software defined vehicle development will also requires a change in how you are structuring your overall organization. What other things are going to get impacted? Of course, the competencies would be a major change. Until now, we are talking about a very strong C-based development in automotive, which is now completely getting disturbed with more C++ or object-oriented programming based. So that's a radical shift in terms of developing a software for automotive. Then the ecosystem will change, a lot of new players, the development methodology will change because you are modularizing many things. Virtualization will pick up a huge competency, and a lot of development will and validation will happen on virtual world than real vehicle validation. And of course, because we are decentralizing many things, all the PLM systems, ALM systems has to come in place. Those will still be integrators in bringing all this vivid data together. Of course, processes will change. We are now talking about model-based systems engineering, continuous integration, DevOps, so agile methodologies, safe methodology. So all these will be a driving force from the software defined vehicle standpoint of view. As I already talked about, the organizations would change because the ecosystem is changing. It is no more that a tier 1 will develop a system, OEM will integrate the system and deliver the end product. After delivering the product also, there are a lot of services which a lot of other players will come into picture. They need to participate, and not just during the development of the vehicle, but throughout life cycle of the vehicle. So all of caters a complete change in terms of how do we handle overall development, engineering side of it, as well as after sales effects. or how do we handle the overall proposition. Finally, I think I will just complete my talk. I think 3 words: change, challenge, and consequence. So change is there, it is required because we are changing everything, not just the technology, the methodology, everything. Of course, this change has to be accepted, and all the players in automotive has to drive this as a challenge. It's not easy, but because it's helpful to all, I think the challenge has to be, and eventually consequences, there will be a lot of benefits coming out of software defined vehicle, not just for the OEM, but also for the end customer. So overall, this will become the main driving force in next 15 years. Yeah, so with this, I will conclude my talk.
Thank you, Mr. Bhangi, for that early insight into the subject of software-defined vehicles. Now, to get an insight into the future of mobility and the why of SDVs, I invite Dr. Tapan Sahu, Executive Director, Engineering, Maruti Suzuki India.
Yeah, morning. Good morning, friends. Morning. Thank you, Dipanshu. Thank you, Mobility Outlook, for inviting me to this conference. It's my pleasure, and to be among the august audience. I thought that when Dipanshu spoke to me about the inaugural, I thought everybody is going to talk about SDVs, what it is, how to do. So let me take up the why part. Why are you talking of SDVs? So let's look at the larger picture, 30,000 feet overview, as to what is defining mobility sector as such, how it has been defined over the last century, and how it's going to step up in future. So, I mean, if you look at the news, pick up and do a Google search, SDV is a hot topic, and there are a lot of things which you see every day, be it collaborative approach, be it working on partnerships or industry defining movements. So that's a hot topic. So what I'm going to do is I'm going to talk to you about mobility evolution. What are the global imperatives which are shaping mobility? And what is really India imperative, and what is our approach as a country? And therefore, how software defined vehicles is going to help us in that regard. So mobility evolution, this is a picture of 1900 in 5th Avenue, New York. And you see a lot of horse carts on the left. And in 13 years, it all changed. So one decade, horses changed to horsepower. 1913, a century, and what you see here is cars changed to congestion. So this has been the urban mobility transformation across the globe. And 5th Avenue, New York, because progressive place, a lot of money, and you see all kinds of changes which are there. In the same century, I think we saw global automobile production landscape also changing, with different countries taking leadership positions in different parts of the century. While the first 50 years was US, then it went to Germany and Japan, and then China, and question is, who is next? Now, this is how it transformed, but what are the global imperatives which is shaping this mobility revolution? I think we need to look at various societal megatrends, which is shaping the mobility megatrends and therefore the auto industry revolution. So I have picked up 5 megatrends which is shaping society and mobility today. The first one is climate change. The graph on the right shows the global temperature rise, and therefore all countries across the globe are talking about carbon neutrality targets starting from 2035, 2050, 2060, and India 2070. So therefore sustainability has become a buzzword, and a lot of technology development is taking place with respect to energy transition, carbon neutrality, and so on and so forth. The second mega trend which is there is demographic change. The world population is almost doubling, more than doubling in about 75 years. And we see the median age across the globe changing in a rapid fashion. India is blessed to have a very large younger population. Third is rapid urbanization. If you look at the 1960 to 2050, urbanization is going to double. We are adding almost 50,000 people a day to urban population. So you can imagine if we are adding 1.5 million people a month, what is the kind of challenge which will be there as far as urban infrastructure and mobility is concerned. The fourth one is digital technologies, be it connectivity, now 6G, cyber security, deep and machine learning, AI, AR, VR and big data. So this is also shaping how things are being perceived, consumed and used by consumers. And also the rising middle class across the globe. The middle class population is almost tripling in about 25 years, 21 years. And that's also giving a lot of propensity to consumption across the globe. So these 5 megatrends are actually shaping the mobility megatrends across the globe, be it self-driving cars or be it different kinds of accommodation that you use or electric mobility. And you see drone taxis, you talk of autonomous pizza delivery or online retailing, and therefore the mobility megatrend of ASS across the globe, because it provides autonomous vehicles provide safer and fatigue-free drive, connected makes it accessible and convenient, electric because of zero tailpipe emission, and shared because of better asset utilization and congestion reduction. And therefore you see a lot of drive or a lot of changes in terms of electric mobility. If you look at just the numbers, in terms of penetration, in China, electric mobility was about 16%, electric vehicles was about 16% in 2021, going to rise to 60% by 2030. And Europe, almost similar numbers. Japan is going to jump multifold, so also India. And overall global electric vehicle penetration is likely to be 40% by 2030. So these changes, these are what is happening across the globe. But what's India imperative actually? India, this century is our century, our country's century, and we are expected to dominate the growth in Asia. We have a growing economy, increasing consumerism and digital exposure. If you look at the numbers of auto industry today, I think we are contributing about 7.1% to the GDP, 49% to manufacturing GDP, and about 37 million people employment. And at the same time, we have it's a unique market. We have a unique consumer. We have high congestion in our roads, high pollution, and also high road accidents. If you look at some statistics, our GDP per capita is 1/9 of US. But at the same time, if you look at consumer side, people want smarter things. Simple survey shows that 62% people want smarter purchases. So on the one hand, affordability becomes a key factor, but smarter solutions are required. If you look at pollution, I think we are infamous for having the highest polluted cities. With BS6, the emission and other things have improved a lot, but we have a lot of vehicles which are old, and these need to be looked at when you are looking at the pollution issue. Consumer psyche is changing, and there is a clear shift towards modern and high social status among people, and the emerging needs of digital technologies and usage of smartphones, tablets, etc. is also giving rise to the need of digital technologies in the vehicles and mobility solutions. If you look at congestion, for example, the average speed in different cities of India is about 20 km/h. And if you look at the graph on the right, the impact on emission, I think from 40 to 20, the on-road emission increases by 40%. So how do we solve these problems of India? Similarly, if you look at energy security, I think a lot of crude consumption, we are importing a lot of crude, and therefore, the move towards electric mobility and other forms of mobility. In terms of road accidents, I think, we have the highest deaths per 100,000 population, and therefore we need safer mobility. So considering and all these aspects, Government of India is taking a lot of initiatives as well as putting a lot of regulations for the auto industry, be it safety, be it recall codes, be it emissions or fuel efficiency. So therefore, if we contextualize the global mobility megatrends, SS, and look at the challenges and solutions for India, we as a unique market, we have value conscious consumers, and therefore we need affordable solutions. We have congestion, connected and shared mobility can help in this. We have high pollution and import bill, so we need environment friendly vehicles, and to take care of accidents, we need safer mobility. So therefore, in India context, probably this is something which can help us in terms of affordable and assisted mobility, connected and shared, eco-friendly and safe. So we need products and services that meets this consumer demand and the regulatory requirements in the Indian context. So in this context, if you look at government's vision and the pathway, Prime Minister Modi has said that, okay, we are in the Amrit Kal, next 25 years is going to define India's future. And the initiatives which government is taking in terms of be it electric mobility, be it the PLI scheme, or the biofuel policy, or hydrogen policy, some of these are taking care of the energy transition. And we'll see a dramatic shift in terms of the powertrain of vehicles in future. So from IC engines to alternate fuels to hybridization to electrification, we'll see a shift and to take care of the India challenges of energy security, pollution and affordability. And it will be it's kind of a technology agnostic approach which will be there, which is going to help the industry transit in a proper manner as well as the take care of the consumer requirements. Second, if you look at the physical transformation, why I say physical? Because the physical transformation of Gati Shakti, connectivity, and the digital transformation. If you look at connect the dots, I think we are going to have a dramatic change in the way we commute, in the way we communicate in future. Third thing is innovation. I mean, there are multiple missions of Government of India. I have just picked up these three because these relate to the topic that we are discussing today. In terms of innovation mission, developing an innovation mindset, I think that's what is going to redefine India's future. And in this context, I think the mobility for future is going to be multimodal and integration of transportation systems, which will enhance accessibility, which will be efficient, and which will ultimately be low carbon system. So this will help us in improving the environment, improving efficiency, reducing length of travel, and reducing the need to travel. So therefore, I mean, if you want to do all this, you can do all this through SDVs. So the why part is that if India is going to transform in the next 25 years, we will require SDVs. This is again a kind of time chart for evolution of software content in vehicles as and when the regulatory requirements came up across the globe or in India as well. I think the software content is changing dramatically as far as vehicles are concerned because of safety, emission, user requirements, infotainment, ADAS, etc. And SDV, I mean, this is a definition that I picked up, which is like defined as a vehicle or described as a vehicle whose features and functions are primarily enabled through software, a result of the ongoing transformation in the industry. So, three key aspects, I think, what I felt is quite important. One is new features and updates on demand. Second is service-oriented architecture and hardware-software decoupling. So, new features and updates on demand can be done for multiple purposes, for enhancing value to the consumer, as well as from the OEM side, I think, for enhancement of features or even taking care of some corrective actions for the market problems. This helps in both ways. Similarly, for the architecture point of view, I think the middle layer is going to be very, very critical as far as SDV is concerned. And decoupling is going to help us in taking care of the lifespan of the vehicle. But it poses another challenge in terms of the initial cost. So when you talk of a range of vehicles, starting from a small car to a larger vehicle, how do you take care of the hardware cost across the segment? So that's going to be extremely critical. So therefore, there will be multiple types of architecture which is going to be used in SDVs. At some level we will have fusion, and this is going to help us in meeting the consumer needs from a basic functional need to updatable or digital or a software defined need. Probably we are at the stage 2, getting into stage 3. For getting into stage 4, it's going to take us some time for India to come. And this is going to change the overall value chain and also the business models for sure. I think if you look at suppliers, automotive enterprise and users, depending on the type of use case and the type of architecture we are going to use, we'll have a multiple type of business models as far as SDV is concerned. And it can't be done by anybody alone. We need a collaborative ecosystem, be it the OEM, the component suppliers, the IT industry, policymakers, mobility and energy operators. That's how I look at SDVs taking shape in India for a future India. Thank you very much.